So here's the sine and cosine back again. Graphed in the calculator by setting the window and being in the correct mode. Here's the sine and here's the cosine. One thing to note is the domain. Right? These waves go on forever in both directions. So what is the domain? It's all real numbers, right? There's nothing undefined about a sine or a cosine. So the domain, make that blue. Domain, all reals. Okay, how about the range? Go ahead, what? Less than or equal to 1, but what about on the bottom side? Right, this is a place for a three-part inequality, you would say. -1 is less than or equal to y is less than or equal to 1. So the values of y are in between -1 and 1. Sine and cosine are always between -1 and 1. You know, if we had a similar kind of problem to those last problems in the homework last night, where it said sine theta equals 1.5123, you would know there's no answer because sine can't be more than 1, right? And that comes up a fair amount when you're solving things, because you definitely solving problems sometimes you get to that point where it says sine or cosine equals a number bigger than 1 or less than -1, and you have to say that means no solution. And then notice that one of these graphs, the sine, as you would expect, right? At 0, at the angle of 0 on the unit circle, sine, the y-coordinate is 0. At pi over 2, it's 1. At pi, meaning halfway around the circle, it's back to 0. At 3 pi over 2, it's -1. And then it's back again to 0. Cosine starts at 1, right? The x-coordinate at the angle of 0 is 1. And then it goes down to 0 at pi over 2. So you follow that through. One of these graphs is just a shift of the other. They're essentially the same shape, completely the same shape, right? It just looks like, right here, we had the highest point on the graph here is at 0, but the highest point on the graph was at pi over 2 here. So this graph here, this graph is this graph shifted pi over 2 to the left. And because they are basically the same graph, if you used a calculator to, let me clear that. If you used a calculator to model, like put data in it, and then try to model it with a trig function, stat, calc, you only see one of those as an option because there's no point having both. There's no point having both. They're the same shape. One of them is just a shift of the other. And you don't see any of the other functions in there at all. So the only one we're really going to use is sine. What kind of things might you be able to model with a graph, with a function that has a graph that looks like this? They're waves. What kind of physical things are like waves? Sound, light. How about the waves? The waves in the ocean, right? So the atmosphere. The atmosphere, somebody described it to me once, it's like we're standing at the bottom of an ocean of air. And the weather is all the waves going over the top. So there's another one right there. Just think of a process like if you wanted to model temperature, right? The temperature is at its maximum in the middle of the day, and then it goes to its minimum, and overnight, then it goes back again, and it does every day. It repeats itself. So these kinds of waves are very useful to model real-world processes.